Hi, this is Mr. McMaster, and we are looking at stream tables today. So this is a stream table. Some of you have already seen these in my class. And what they're going to have in them is, right now we have some fine sand, so some really fine coarse ground rock. And we're also going to have some bigger chunks of rock, which are like pebbles in this stream table. We're going to be looking at the lab, so it'll be activity 1. And we're going to look at the problem, what effect does running water have on rock fragments of different sizes? So what effect is it going to have on these sand pieces, and what effect is it going to have on these big chunks of rock when we pour it down the stream? Now we're going to be looking at two different beakers of water. They're both sitting at 1 liter, and so that's both the same amount of water. And we're going to pour one beaker very slowly, and we're going to pour 1 liter very quickly. And so what I want you to think about is, what are the different variables going to be in this lab? You need manipulated, responding, and what are some controlled variables we might be using? That's right! Your teacher must be teaching you variables very well. So let's start now with our slow water. We're going to pour the water really slowly, and we're going to see what happens while we pour the water slowly into the stream here. Now you'll notice while the water's being poured, you can sort of see that, if you look and pan in closely here, that a lot of the small sand is being taken away and washed downstream. You can also see that most of the bigger rocks are staying in the place. They're not being affected very much by this slow speed. If you look at the stream shape, you can notice that obviously some of the soil is being eroded. And we are done with our 1 liter. Okay, now we're going to look at some faster moving water in the same shape of riverbed. So let's check it out. And if you notice this, you can see a lot of different shapes that have formed in this river as opposed to the small one. You can see that, again, lots of the sand has moved to the bottom and the bigger chunks are left behind. But if you look at the edges of the riverbank, you can see that it's carved almost underneath the edge of the riverbank, as opposed to carving a nice U shape. It's more of a square-shaped carving pattern. What effect does the shape of a river have on the amount of erosion and deposition? We're going to look at a curved river, and as you can see here, there's a bit of a curved river, and we're going to look at it in comparison to a straight river. So I want you to think again about what the different variables are going to be.
That's right!
Notice on this part here that on the inside curve that the rocks are being deposited, and on the outside curve that it's being eaten away almost underneath the bank of the river, and you'll quite often see that in the rivers in Edmonton. Okay, and we're going to try trial number 2 now, which we are going to pour at the same speed just down a straight slope, and we're going to see how that affects the river. So if you look at this river here, you can see that once the water has run through, that you can see that it's just a wide river. It's got very wide banks, and this is a quite common characteristic of a straight river. Stream slope, and we're going to look at the problem, what effect does stream slope have on the amount of erosion? I want you to think about the different variables that there will be in this experiment.
That's right!
Start our tests here. We're going to start off with the low slope, and let's check out how our water works. Alright, so for this low stream shape, you're going to notice that there is basically the same shape after we pour the water, and there's going to be a little bit of erosion. So we're going to start trial number 2 here. Now you'll notice that the slope of the ramp has one brick underneath it, so it's going to be a little bit steeper in this case. So let's check it out. Looking at the shape of the river after here now, and you can see that it has carved almost a straight path straight down. It's going to go with gravity, and it's going to take all that water with it the easiest way it can, which is going to be straight. And if you notice at the top here, a lot of the big rocks are left, but especially at the bottom there's a ton of the sand that's just moved down and washed through. Alright, and this is our last and steepest slope here. We're sitting on a little bit dangerous there if you look at the brick. It's kind of wobbly, so let's check out this last one here. We're going to pour it. Same thing, ready, let's go. Alright, so you'll notice in this last trial that there's almost no sand left on the bottom of where the river was. It's all the big rocks, all the small rocks, if you look especially at the bottom, are deposited in a big pile there. Also notice that this is a very wide river, again because it's eroded a lot of the sides of the river. So that is the end of our stream characteristics lab. Thanks to Mrs. Rosewell for her awesome filming of this amazing lab.